Assalamualaikum and hi. Welcome to our video presentation for subject MAT272 Introduction to Mechanics. So today we are from group RCDCS 143B will be presenting about application of mechanics in real life. And our selected topic is vertical motion under gravity. So let's begin our video presentation. So these are my group members. So before we get any further about our video presentation, I would like to introduce to you each one of our group members. So on the left side, which is me, my name is Amir Haziq bin Muhammad Wira and my matrix number is 2022-892508. And beside me is Muhammad Azrin Aizam bin Jamaluddin and his matrix number is 2022-843308. And on the right side is Muhammad Aidil Hakim bin Nur Azizi and his matrix number is 2022-627522. And beside Aidil we have Muhammad Haris Haikal bin Zahrin and his matrix number is 2022-885062. So you guys already knew our group members. So before any further ado, let's begin our video presentation. Let's begin with introduction. So vertical motion under gravity, which is our selected topic, is a fundamental concept in physics describing how objects move when influenced by the force of gravity. Whether an object is dropped from a height, thrown upwards or projected at an angle. Its motion follows specific principles by gravitational acceleration. So this case study explores the key aspects of vertical motion, including acceleration due to gravity, equations of motion, and the impact of air resistance. By examining in real-life examples and theoretical scenarios, we actually aim to calculate the maximum height of the ball from top of the building and the velocity when it reaches on the ground. Basically, in this kind of situation, it actually uses 4 different formulas. Like the first one is V is equals to U minus GT, which is to find the velocity. The second one is S is equals to 1 over 2 bracket 2U plus V T to find displacement by average velocity. And the third one is S equals to UT minus by 1 over 2 GT the power of 2, which is to find the displacement by initial velocity. And the last one is V square equals to U square minus by 2 GS, which is to find the velocity squared by the displacement.
So, let me proceed to the discussion. From the video, we can draw the diagram based on the situation. We assume that the height is 7 meter and the initial velocity is 6 meter per second. From the situation, we need to calculate 3 things, which is calculate the maximum height of the ball from the top of the building, the time taken from the top of the building to the ground, and finally, the velocity of the ball when it reached the ground.
Next, I'm going to show the calculation for the first equation, which is we need to find the maximum height of the ball from the top of the building. Firstly, we need to use the fourth equation, which is V square is equal to U square minus 2GS, where V is final velocity, U is the initial velocity, G is acceleration of the gravity, and S for the displacement. After that, we need to substitute the value of U is equal to 6 meter per second, G is equal to 9.81 meter per second square, and V is equal to 0 into the equation. And then, we will get the value of S is equal to 1.83 meter. To find the maximum height of the ball, we need to add the height of the building with the displacement, which is 7 meter plus 1.83 meter, and we will get the maximum height of the ball is equal to 8.83 meter. So let's continue to the next question. For the second question, we need to find the time taken of the ball from the top of the building to the ground. The equation that we need to use to solve this question is S is equal to ut minus 1 over 2 gt square, which is the third equation. After that, we substitute S is equal to negative 7 meter and u is equal to 6 meter per second, and then we will get the value of t is equal to 1.96 second. The value of 1.96 second show that the time taken of the ball from the top of the building to the ground.
Assalamualaikum. I will continue to the question 3. The question is, what is the velocity of the ball when it reaches to the ground? For this question, we can use the first formula, which is V equal to U minus GT. From the question before, we already got the time from the ball reached to the ground is T equal to 1.96 seconds. So we can insert that to this question. V equal to 6 minus 9.81 times with 1.96. We calculate that, then we get V equal to negative 13.23 meter per second. So, conclusion, we can conclude that free-falling bodies move vertically under constant gravitational acceleration g without a resistance. Using the convention A equal to negative g, the motion equation are: the first one is V equal to U minus GT for final velocity. The second one, S equal to 1 over 2 times U plus V times T for displacement by average velocity. Third one is S equal to UT minus 1 over 2 times GT square for displacement by initial velocity. And the last one is V square equal to U square minus 2GS for final velocity squared by displacement. This equation helps solve free fall motion problems.